Now coming to application of Archimedes principle about relative density. First let us take about the relative density of a solid. That we write as a solid. Relative density of solid is nothing but of the body divided by relative density of water at 4 degrees Celsius. Relative density of solid is ratio of density of a body to that of density of water at 4 degrees Celsius. It can be written as weight of the body in air to apparent loss of weight of the body in the given liquid. This gives you directly the relative density of the solid, comparing that of the body, solid body with respect to water. If you know the weight of the body in air and weight of the body in liquid, so it is clearly says denominator part is the apparent loss of weight of the body. Therefore, I can write this also as weight of body in air to apparent loss of weight of body in liquid. That gives you the relative density of the solid with respect to water. The second is relative density of liquid. This is again apparent loss of weight of body in a liquid or given liquid to apparent loss of weight of body in water. So that means this is of liquid if you want. Weight in air minus weight in liquid by weight in air minus weight in water. So there are two relations most important as per the solutions concerned in questions appearing in NEET and appeared also on the basis of these relations. One, relative density of solid and relative density of liquid, comparing density of the liquid with respect to that of the water. That measured easily using the relation apparent loss of weight of the body in liquid. When we take the body into a given liquid, there is a loss in the weight. That is measured nothing but knowing the weight of the body in air and weight of the body in liquid. Similarly, apparent loss of weight of the body in water, weight in air, that of the body, minus its weight in given water. That relation gives you both relative density of solid and relative density of the liquid. Hence they are asking about the density of mixture if they mix minimum 2 liquids or maybe more. I give you for relation for the 2 liquids mixed. Density of the mixture can be written as ρ1 V1 plus ρ2 V2 by V1 plus V2. It is nothing but total mass by total volume. So here ρ1 density of the first liquid and V1 is its volume part. V1 part in a given total volume V. V1 part is of density ρ1 and V2 part is of density ρ2. The mass of the first liquid, mass of the second liquid, total mass by volume of first liquid, volume of second liquid, total volume. It is not different relation. Total mass by total volume gives you the density of the mixture. If V1 equal to V2, if both are in equal proportion, then the relation becomes more simple, equal to ρ1 plus ρ2 by 2. V cancels. Instead of this, if they given in terms of mass, then only also we can go with the total mass as m1 plus m2. Wherever V1, I write it is m1 by ρ1 plus m2 by ρ2, because you are knowing that mass is equal to volume into density. Volume is mass by density. So if here also if m1 equal to m2, mass of both liquids are equal, then you can write this as 2 into ρ1 ρ2 by ρ1 plus ρ2. Don't think it is only for two liquids in different proportion taken. It may be for any number of liquids. Here too, if the third one is comes plus rho 3 V3 divided by V1 plus V2 plus V3. Or if here given in terms of mass M1 plus M2 plus M3, again another term here added plus M3 by rho 3. Condition for floating of a body. Most important to not only helping to know the last condition of flotation, but helping you to measure the density of or relative density of substances. Weight of the body in air equal to weight of the liquid displaced. So whenever we want to take a body into a liquid of any shape, so the two forces are acting. One is directly below, that is weight of the body, mg. Another, there is an upthrust, net upthrust, that is called as a force of buoyancy. In the previous two cases, discussion of force of buoyancy and also in Archimedes' principle, I stated that force of buoyancy is nothing but equal to weight of the liquid displaced. When upward force is equal to the downward force, the body remains in equilibrium position. And most important relation, as we go to the problems, you come to know how it helps in measuring density. Weight of the body in air equal to weight of the liquid displaced. And the second is center of buoyancy and center of mass of the body must lie on the same vertical line. They must lie on a same vertical line. If it may be the center of mass, I can call C. It may be the center of buoyancy, FB force. They must lie on a same vertical line. These are the two conditions usually referred and you studied in your regular first year PUC. Apart from this, we take the concept of metacenter. Whenever a body is oscillating in a liquid, so it may be tilted to some extent, and we are seeing this body position is like this. Originally its vertical line is here. It may be the center of mass C. Center of buoyancy, the force of buoyancy acting point, is somewhere at B here earlier, but more portion of the liquid is immersed and this center will be little bit shifted towards the right. The new center of buoyancy is found to be at a different point rather than earlier. Now if you draw a line vertical, it will intersect the original line about a point. That intersecting point is called as a metacenter of the body, metacentric point. And distance between center of mass and metacenter is called metacentric height. And what is the importance of metacenter point is, for stable equilibrium of the floating body, metacenter must be above the center of mass. That means C and M must be above the center of mass. For unstable equilibrium, metacenter is below C. That means M comes below than C. This body sinks not tilt. Neutral equilibrium, metacenter coincides with this. However, this is stable equilibrium always in designing the ships or any floating bodies. they use. Suppose if the situation comes like this or like this, more dangerous, and it happens to be the case of the Titanic that we learned or we experienced by our seniors. So that is about this chapter, the first one, about the starting with the thrust, the normal force exerted by liquid on the solid surface coming in contact with it, and come to the second one is a liquid pressure, that is force by area. Most important tool is about the pressure acting at any point inside a liquid relation, OGH, called as a Gauss pressure, and also liquid inside at any point experiencing two pressures. One is atmospheric pressure and the other is the Gauss pressure. Together we call it as absolute pressure. Absolute pressure is equal to the atmospheric plus the Gauss pressure. And application of the pressure we understood. And further we come to the principle of force of buoyancy and Archimedes. Any body taken into a liquid experiencing the top and bottom surface of different thrust and net upthrust that the body experiences in a liquid, we call it as a fluid, force of buoyancy. And further by studies we come to know this force of buoyancy is nothing but equal to the weight of the liquid displaced or apparent loss of weight of the body. However, the principle of Archimedes, you learned with the story in the lower standards also, his story, how he come to know about the apparent loss of weight of the body and displacement of the liquid when some body is immersed into a liquid. Actually, the law is whenever you keep or immerse a body partly or completely into a fluid, it will displace equal volume of liquid which is immersed part. However, that again when we compare to force of buoyancy, we understand that Archimedes principle can lead to that idea. Weight of the body in air is equal to the Archimedes principle, apparent loss of weight of the body is equal to apparent loss of weight of the body is equal to the force of buoyancy, or it is equal to the weight of the liquid displaced. And Archimedes principle applications, the most important is relative density or density of a substance. Density of substance is mass per volume. If you measure the volume of any irregular body using the Archimedes principle by immersing it into any liquid, knowing the mass, finding the ratio, we can measure the density of a substance. Or relative density of solid if you require, it is nothing but weight of a body in air to weight of the body, the apparent loss of weight of the body in a water or liquid. That is WA divided by WA minus WL. That gives you the density of solid. Density of liquid, take the body into the liquid first, measure its weight, and also take into the water, measure its weight in air. Then the ratio. Apparent loss of weight of the body in a liquid to apparent loss of weight of the body in water gives you the relative density of the liquid. WA minus WL by WA minus W water. And coming to lastly about the loss of flotation. For any body to float, the two forces are acting on the body when you throw into a liquid. The number one is its own weight, which is acting downward due to gravity. And another force is force of buoyancy, which is acting upward. So if force of buoyancy become equal to that of the weight of the body, then there is a chance of body to float. If force of buoyancy become less than the weight of the body sinks. If just become equal, just it is floating at the surface. As the force of buoyancy increases compared to the weight, the certain portion of the body appears to be more and more above the liquid or water. However, we lastly taken the concept of Metacenter. Metacenter is a new point, a new force of buoyancy with vertical line intersecting, and it should be always above the center of mass for equilibrium of the body on the floating liquid. With this, we conclude and go to the next part, that's about the surface tension.